Hello everyone, my name is Bradley Shoemaker, and this is my presentation on the Sierra Nevada mixed conifer ecosystem and the fire regime that dominates it. To start, to give you all an example, there's a good picture on the bottom here from Yosemite National Park, giving kind of an example of the area that we're going to be discussing. So species summary. On the right, there's a chart from the U.S. Forest Service in 2018 kind of discussing overstory species that are dominant in the yellow pine and montane mixed conifer communities that we're going to be looking at today. If you look, there's going to be a lot of fir, Jeffrey pine, ponderosa pine, sugar pine, and even some more fir. Some notes is that these are not all necessarily occurring together. They're just considered the general mixed conifer area. They may grow in slightly different areas or kind of have their own little subset within this mixed conifer forest. But across the landscape, these species have historically supported low to moderate severity fires that maintained kind of a heterogeneous, even-aged forest structure with, when you think about it, large, well-spaced, fire-resistant trees, where by that I mean, they're going to have grown tall, they have thick bark, they're, not really present with ladder fuels, and small gaps in the canopy, which is where most of their seedling recruitment would come from. Recently, they've seen an increase in fir species due to fire suppression. That's been documented in studies. That's significant because this changes the fire regime and how it's burning long term, so we may start seeing pretty significant changes in fire regime on the landscape. The major concern of natural resource management in this area is the historical exclusion of fire, overstocking of stands, also known as fuel loading, and resilience of ecosystem to drought and other disturbance effects due to having essentially too many trees in the landscape competing for the same resources. So ecosystem location, this is a map of land cover distribution in California. We're not looking at all of the colors, but we're really going to be focused on the blues and the other ones labeled mixed conifer, which is kind of that light coral color and a dark coral color found way up in the northern part of things. But that dark blue color is going to be your significant piece. If you look in California, that big flat area in the middle, that's the Central Valley. So we're looking east of that. This is not the coastal habitat, and we're looking really in those Sierra Nevada mountains. The mixed conifer forests are present roughly from 4,000 to 7,500 feet in elevation, which is a big distribution across this, but there's significant habitat in this area of alpine and subalpine ecosystems as the range goes up to almost 14,500 feet, with the highest peak in the continental United States, Mount Whitney. There's plenty of other forests around these areas, California black oak, bristlecone pine at the higher elevations, as well as those alpine and subalpine ecosystems that we discussed already. So ecosystem description. The best description I can give are these photographs here on the right. The bottom one, and actually even the top one, demonstrates it. They've been having a huge mortality event related to drought in California, which is driving fire behavior and resistance to suppression and a whole bunch of other things. But you can see it in that bottom photo very well from Smithsonian Magazine and University of California, Merced. The mortality of these trees on the landscape is significant, and it changes the fuel loading from that live fuel component to a dead fuel component, adds the leaf litter and the needle cast, and then the heavy fuel component that burns for a long time, causes soil impacts. It's really a tough ecosystem to be working in right now, and it's expensive to mechanically go in and alter this. So it has historically departed from that open ecosystem that we talked about. As you can see on the bottom picture, it's very different from the title slide. And significant changes in the ecosystem to make it less resilient has brought around this mortality. Drought and more dense forests has led to the death of nearly 150 million trees just in the state of California, I think it was. So the historical fire regime that we talked about was fire regime 1, 0 to 35 interval, mostly low and moderate severity fires. There's a representative photo on the right in there, and I just want to keep everybody's picture in their mind. that moderate severity fire can still go up between 25 and 70% tree mortality with moderate effects on the soils. It's not until you get above that 75% tree mortality that you really hit high severity fire and significant impacts. The major effect of these natural fires, historically speaking, was to kill small trees and saplings, thus maintaining the open stalking and sparse understory, also known as ladder fuels, that we are now seeing loaded today after 100 years of fire suppression. Historically, fire season ran from June to October. That's seen some significant increases. We're going to look right here. So we talked that, that top photo there is the historical condition. The bottom photo is the current condition. You can see a lot more ladder fuels, a lot more young growth, the ability for fire to move from the ground to the canopy and then thus burn and kill overstory trees. It's really a significantly changed ecosystem. And unfortunately, the ability to go in and take out a lot of these smaller diameter species doesn't produce significant amounts of commercial product, so it's hard to offset the cost. Fire exclusion did start in the early 1900s, same as we've been seeing all semester, with increased settlement and the establishment of the U.S. Forest Service and the Great Fires in 1910. That was a real watershed event for us. Present forest conditions we've discussed already. When we look at how much fuel or vegetation or anything is on the landscape, we're talking about a doubling of live tree carbon stocks, also known as fuel loading, compared to that historical level. That's a big significance when you talk about putting fire on the ground and what the impacts will be to the ecosystem, to the soil, the ability for that, hot air to get up and out and escape without burning other trees. It's a real departure, and the ability to take it back to a historical condition, one, requires some skill, some money, and also the ability and the social license from the surrounding communities to induce that mortality in that moderate range of 25 to 75% with things like prescribed fire or managed fire. The current fire regime that we're talking about is estimated to be 75 days longer and have elongated fire intervals. According to CAL FIRE, we're talking about increases in length of fires, acreage of fires, larger pockets of high severity fire compared to historical fire conditions, and certainly the longer fire season with overall more effects on the landscape. This moves us more into a fire regime class 3, which is a 35 to 200 year interval with moderate severity, and fire regime 4, 35 to 200 year intervals with high severity. That's a big departure from that fire regime 1, 0 to 35 years with low to moderate severity, because the recovery of the ecosystem and the resiliency of the ecosystem is not there to support those fire intervals. The photo on the right there is from the August complex last year. It's really the first fire in California to exceed 1 million acres in modern day suppression history. Current issues across the state, none of these are significantly new to our discussion, but they are all coming to a head in the same place. So we have wild and urban interface development. Obviously, housing in California is a big discussion nationally. It's pricey, it's expensive, and they put it a lot of places that it doesn't necessarily need to be. Climate change is impacting California pretty significantly, and the movement away from historical fire conditions historical forest conditions over the last 100 years is certainly something to discuss throughout the West, and will not be solved overnight. So restoration of forest conditions is something that they're working to achieve, but obviously takes time. And then drought and disturbance related mortality, as we talked before, is really causing them quite a bit of an issue because it changes so many things when you put that much dead fuel on the landscape. So this leads us to our last point, that there's a significant number of compounding disturbances, including climate change, drought, insects, disease, fire, fuel loading, that contribute to this. And we're not trying to solve one problem on a landscape. They're trying to solve half a dozen of them, all existing in the same acre at the same time. Future management, when we look at the ability to manage these acres and what needs to be done, there was a study done with a control group and the potential for mechanical thinning or mechanical treatments, mechanical plus prescribed fire and prescribed fire only. Clearly, the mechanical as circled in red there didn't have as much of a change from the control group all the way on the left. By putting that fire on the ground, you are able to reduce surface fuels, and that is the biggest component of reducing forest fire hazard and thus increasing forest resiliency, decreasing fuels. Unless we really start putting fire on the ground, all the mechanical work in the world isn't going to, in my mind, meaningfully change our fire hazard, because there's still that fuel loading there that will burn and will burn hot. These are my references. I believe it's 2 pages actually. There's a lot of research that's been done in this area. There's a lot of fire that burns in this area, and I really enjoyed doing this, but there's plenty of information out there. What's not necessarily available is the horsepower and the funding and the time to get it done in a quick turnaround. Thanks.